students, welcome back. This is Torres, elbow bump. How are you? Are you doing okay? Is your family okay? Remember, if you need anything, please send me an email, and I promise to help in whatever way I can. So lucky you get to hear my voice for another lecture. But the best part is we will be continuing to work with the 4 steps of hypothesis testing. Today we're going to be working with means when we know the population standard deviation. Yay! So let's review the 4 steps to hypothesis testing. In the first step, you need to write your null and alternate hypotheses. You're going to state these hypotheses in terms of the population parameter. So if you're working with proportions, you're going to use the notation of P. If you're working with means, you're going to use the notation of mu. The null hypothesis states the status quo, what's happening at the moment, what is believed to be happening in the population. The alternate hypothesis asks the question, addresses the question of the experiment or the study. So in that case, you're going to be looking at the question that is being asked about the population to know how to write your alternate hypotheses. The second step is the prepare step. In that step, you're going to be doing things like selecting a significance level because you want to reduce your amount of type 1 error. You're also going to be finding the test statistic, in this case the ZCrit, that matches that significance level. You're going to be deciding what kind of test you need. Do you need a 2-tailed test, a 1-tailed test? If you need a 1-tailed test, do you need the left one or the right one? You're going to be checking requirements. So if you don't get information within the problem that your data has a normal distribution, then you're going to have to use the central limit theorem to be able to verify that the data is normally distributed. In the prepare step, you are also going to be creating a model with your null hypothesis proportion or mean value in the center with a z-score of 0, marking your ZCrit, establishing the area of rejection and the area of retention, and also calculating your standard error. So the prepare phase is a really long phase. Once you have completed the prepare phase, now you could go into the compute to compare stage. In that stage, you are going to be calculating your Z obtained. So you're going to be taking your sample value, either your sample proportion or your sample mean, subtracting the null proportion or null mean, and dividing that by the standard error. That will be your Z obtained. You're going to compare your Z obtained to your ZCrit. This is also the time where you calculate the probability or the p-value of your Z obtained and compare that to your alpha. If your p-value is greater than your alpha, then you are going to retain the null. If your p-value is less than your alpha, then you can reject the null of no difference. Finally, in the last stage, you're going to decide if you're going to reject or fail to reject, which is another way of saying retain, remember, the null hypothesis, and you're going to state the conclusion in the context of the study. In the last video, we worked with an example with proportions. In this video, we're going to look at a situation where we are working with means and the population standard deviation is known. So it's really important that you distinguish that. In this example, the mean and the standard deviation for the population is known. Okay, so let's look at this example. This one is about college jobs. It says, according to the U.S. Department of Education, full-time graduate students receive an average salary of $12,800 with a standard deviation of $1,800. The Dean of Graduate Studies at a large university in Pennsylvania claims that his graduate students earn more than this. He surveys 46 randomly selected students and finds their average salary is $13,445. using a 5% significance level. Is the dean's claim correct? Okay, so I came over to Ziteboard and I went ahead and did the same thing as the last video. I went ahead and put the steps of the hypothesis tests at the very top. And then here I went ahead and put in the problem that we were working in so that we had it all in one place. Awesome. So let me read the question again. It says, according to the U.S. Department of Education, full-time grad students receive an average salary of $12,800 with a standard deviation of $1,800. Okay. The Dean of Graduate Studies of a large-scale university in Pennsylvania claims that his graduate students earn more than this. Okay, so that's going to be important in the hypothesis. More than this. He surveys 46 randomly selected students and finds their average salary to be $13,445. Okay, and we're going to be using a 5% significance level to test the dean's claim. So I kept the colors the same. I'm going to do the hypotheses in green. So my hypothesis here is going to be H naught. And this time we're working with averages, right? We're working with means. So here it says average. Yeah, average. So we're working with not proportions, not percentages, but just averages. So this time, since we're working with averages, we've got to use the notation of mu, because mu is the notation for the population mean. And they're saying that the average salary is $12,800. So I've got $12,800. Now I've got to write the alternative. The alternative is going to ask the question. It's going to address the question. And it says, the dean at this other school claims that his grad students earn more. So we want to know if the mean is more than what is considered to be the population average. So these would be our two hypotheses. This is the first step here. Okay, so the hypotheses are done. So now let's make a little bit of room and we'll start the prepare phase. Now remember, the prepare phase takes a while to do. Let's see, I'm going to go ahead and make my pencil red, and I'm going to put everything that we're doing in the prepare phase in red. So here in the prepare phase, we're going to choose a significance level and the test statistic, check the requirements, all that good stuff. Okay, so the significance level has been given to us already. The problem asks that we use a 5% significance level. So I'm going to have my alpha at 0.05. And I also need to select my test. So right here, I see that I'm going to have a right one-tailed test. So I need a right one-tailed test. And I need my ZCrit for that test. So I'm going to go ahead and go to the ZCrits for common significance. I've got a right one-tailed test for 5% alpha, and I'm going to find that my right one-tailed ZCrit is going to be positive 1.645. So that's going to be my ZCrit. Looking at my problem, I can also write down my sample size. So my sample size is 46. I know that the X bar, the sample mean, is $13,445. I'm going to go ahead and write mu out here as well in case I need it. So the mu was 12,800. And the standard deviation, remember standard deviation for population has that like little O with a little tail at the top. And the population standard deviation was $1,800. Okay, so let's see what I've got here. Let me go ahead and draw my model. I'm going to scooch this up just a little bit. Wonderful. Okay. And this is going to be my mix. Okay, so here my z-scores are going to be 0, 1, 2, 3, and the opposite direction is going to be -1, -2, -3, and in the middle I have 12,800, and I'm just going to make this big because it's really hard to write when stuff is little. Okay, so I'm going to try to write 12,800 right here. So this is going to be 12,800. And I need to find this distance for my standard error. So I don't have anything in my question, I don't believe, that tells me that my information is normally distributed. No, so I've got to apply the conditions of the central limit theorem for means. So this one's a little bit different than the ones for proportion. First, you need things to be randomly selected and independent. It does talk about it being randomly selected here, so I'm going to go ahead and assume that this meets the criteria. Second, you have to have a large sample size. And for our work, we're going to say that anything larger than 30 meets the criteria. If the sample size n is larger than 30, it's going to meet the criteria, and we have our sample size as 46, so it meets the criteria. Finally, we need to make sure that our population is larger than 10 times the sample size. So our population has to be bigger than 10 times n. So our population has to be bigger than 10 times 46. And so our population has to be bigger than 460. So is there more than 460 grad students in the United States? Yes. So that also fits. So we can assume that our distribution is normal. Now we need to find this distance here, which is our standard error. So our standard error is our population standard deviation divided by the square root of n. So we've got our population standard deviation is 1,800. That's going to be over the square root of 46. And now I can bring my handy dandy Google calculator over. 1,800 divided by the square root of 46 equals 265 and 40 cents. Because this is money. So we're going to round to where it has money. So this is be $265.40. So this distance is going to be $265.40, this one, etc. So I'm going to just write one of those down. I apologize if this zooming in and out is difficult on your eyes. I hope I'm not giving anybody motion sickness. I just can't write that tiny. Okay, so this is going to be, I'm just going to round this to 265 to make this a little bit easier, and then we can, okay, I guess that's going to have to work. Okay, so I've got 1,200, got 12,800 plus 265 equals 13,065. And now I'm going to add it again. Plus 265, 13,330. Add it one more time. 13,595. And I'm going to go ahead and just, because I'm trying to be a good model for you guys, mark the other areas too. Oops. So to find the raw score that matches the z-score of -1, I'm going to say this is 535. Subtract another 265. 12,270. And subtract the last 265. 12,005. Okay, so here's my model. It's all laid out. Let me zoom back out. Okay, so let's mark the areas of rejection and the areas of retention. And I'm going to go ahead and mark that in blue just like I did the other day. Okay, so my ZCrit is positive 1.645. So positive 1.645 is going to be right here. And it's saying that if a Z obtained is larger than positive 1.645, so this area right here, I'm going to reject. Anything less than that is going to be retained. So if I get a Z obtained that is larger than my ZCrit, I'm going to reject. And if I get a Z obtained that is less than my ZCrit, I'm going to retain. So all of that was in the prepare stage. Now we're going to go into the compute and compare part. This part I'm going to go ahead and do in pink because that's what we did before. By the way, let me know if you think that is magenta or fuchsia. I'm going to say that is fuchsia. Do you agree or disagree? Comment down below. So now I've got to compute my Z obtained. And my Z obtained is going to be my sample mean minus the mu divided by my standard error. And I'm going to scooch this up to give myself just a little bit more room. Okay. Go back to pink. Okay, so my Z obtained is going to be my mean, which was $13,445 minus my mu, which was $12,800. I'm going to leave the dollar signs off because there's a lot to write and it's not easy to do. I know I make it all look so simple. And this is going to be divided by $265.40. Okay, need my calculator. Come here, Google Calculator, do your thing. So I'm going to clear this out. Clear, clear, clear. And I'm going to go ahead and punch this in. So this is 13,445 minus 12,800. That gives me my numerator. Hit enter, divided by 265.40. Hit enter, and I get 2.43. So my Z obtained is 2.43. Now I need the probability of obtaining 2.43. So in order to find the p-value that matches a Z obtained of 2.43, I need to go to my normal distribution calculator, and I'm going to use the same one that I used yesterday. The link is in the description box below. This is a free calculator. So in the population mean, I need to put in 12,800. So if you recall, when we made our model, that was the number that matched up with a 0 z-score. Now for the standard deviation, we're going to use the standard error that we calculated. And our standard error that we calculated was 265.40. Now I want the probability of an x being greater than our mean from the sample, which was 13,445. Okay, and I'm going to go ahead and hit show me an explanation and hit compute. Up here, we see that the probability of obtaining that Z obtained is 0.0075, right? It's way up here. We had set the ZCrit to be 1.65, so it's going to be right about here, and we said anything above that we're going to reject. We also said that if our p-value was less than our alpha, we were going to reject. And this number is less than the significance level, the alpha, that we used, which was 5%. So right now, both the comparison with the Z obtained and the ZCrit works out, and also comparing the significance level, or the alpha, right? That's another name for significance level, and the p-value also tell us to reject. So right now we have all the information we need to be able to reject the null of no difference and say that there is sufficient evidence that students in this school earn more money than the national average. So let's go ahead and put that into context now. Okay, so let me go ahead and write that into Ziteboard here. So we found out that the probability of a Z being greater than 2.43 is 0.0075. And just to recap, we're going to compare our ZCrit to Z obtained. Our ZCrit was 1.645 and our Z obtained was 2.43. So if we came up here, we said that if we got beyond this line, we would reject, and we ended up right here. So we ended up in the rejection area. So this says reject. We also said that our alpha our risk of committing a type 1 error, we were going to risk 5% chance of committing a type 1 error, and we actually got for our p-value that if we rejected, we would be committing a type 1 error only 7.5 times of every 1,000 trials. So this also tells us, yeah, go ahead and reject. Okay, so the last part is asking, what does this mean in context? So let's go back to our problem right here. And the original problem was, according to the U.S. Department of Education, full-time graduate students receive an average salary of $12,800 with a standard deviation of 1,800. A dean had claimed that his graduate students actually earned more than this, and according to his sample, there is significant evidence that his grad students earn more than the population average salary. All done. So let's just recap the steps. So in the first step, we reviewed the scenario and we wrote down the null and alternate hypotheses. In the next step, we prepared. So that included selecting the test, finding the ZCrit to match the alpha that they gave us, calculating the standard error, creating a model and marking off the area of rejection and the area of retention, and also checking to see if the conditions of the central limit had been met, because nothing in the scenario told us that the distribution for this variable was normally distributed. In the compute to compare section, we went ahead and calculated our Z obtained, and we also calculated the probability for our Z obtained. We compared our ZCrit to our Z obtained, and we found that the Z obtained exceeded the ZCrit. So there was evidence to reject. We also compared our p-value to our alpha. We found that our p-value was less than our alpha, so we went ahead and rejected. In the final step, we are supposed to interpret the outcome in context. So we found that the p-value was less than our alpha, and we will reject the null hypothesis of no difference. In order to state the conclusion in the context of the study, we would say that there is significant evidence that the grad students at the Dean's College earn more than the population mean of $12,800 per year. So what's the big idea? Today's big idea is the 4 steps of hypothesis testing provide a systematic process to answer a research question concerning the population parameter. The 4 steps are hypothesis, prepare, compute compare, and interpret. So that's it for today. With that said, don't forget to check your emails, check Blackboard, do your homework, and subscribe to this channel. Even better, hit that notification bell so you know when there are new videos for this course. Okay, this is your teacher Tora saying stay safe, and I will be waiting to give you a virtual elbow bump in the next video. Ciao!